Hopefully you can see us on LinkedIn and on Zoom and everywhere else.
Yeah, and we'll share the recording after too. Um, I think this is actually my first webinar, so I've done a lot of these calls with customers and with prospects. I actually see a handful of people on there. Good to see everybody. Thank you so much for your time today. Just a little background on what we're talking about. It's really difficult to optimize Kubernetes nodes, as I'm sure some of you know. There's a couple key factors that go into that. Of course, there's hundreds of options for node types in the cloud. And as well as your application, every application is different. So they all require different requests and limits that then impact the sizing of the nodes. So we're going to be talking about all of that. Just to give you a quick introduction, my name is Matthew, and I work at Perfect Scale. I've been in this space for about 5 or 6 years now, cloud optimization. I used to be at NetApp, and there I was working on overall storage optimization. And then we got into the Kubernetes space. I started to get some certifications and realized the need for automating the right sizing of Kubernetes. There's a huge need for that. And so I joined Perfect Scale, and Anton has a much better background, so he'll be giving a lot of the details today. But Anton, if you want to go ahead and introduce yourself.
Well, define better. Actually, like saying you have more wounds than me, then that's probably better, right?
Sure.
Yeah, but in general, yeah, I'm Anton Weiss, and I bring the message of continuous optimization for Kubernetes at Perfect Scale, and I've been doing consultancy, DevOps platform, in general, software delivery optimization consultancy for the last 15 years. Um, because optimization has lots of faces, but in the end, if you really want to be excellent at engineering, the stage comes, and it comes pretty early in our process when you want to optimize, and
Absolutely.
that's exactly what we're talking about here.
Awesome. So yeah, this will be pretty interactive. There's the chat, so please post any questions you have in there, and we'll get to those, as well as we're gonna have some polls throughout this just to hear from the audience how you guys are using Kubernetes, whether you're using things like HPA, VPA, or Cluster Autoscaler, or Carpenter. So it'll be pretty interactive. Just keep an eye out for that. But just like Anton was saying, we're gonna jump in, and the first big question is, how much is it going to cost to run Kubernetes?
Yeah, so as I said, at a certain point, the question of optimization comes up. But even before that, before thinking about optimizing, uh, Kubernetes is a great technology. Like only today, I had this discussion on LinkedIn about Kubernetes being like this whole toolbox full of exciting tools, and of course, engineers are very excited about that, and they want to migrate existing projects to Kubernetes, or when we're starting a new IT project, definitely the Kubernetes is the go-to technology. And nowadays, it's pretty easy to spin up a new cluster. Like it's a no-brainer, right? But then, we're engineers, and the business will come around and say, "What is this going to cost me?" Like it's
Yeah,
all cool. I understand the power of this technology, but by the end of the day, we're paying for this, and how much is it going to cost?
absolutely. And also, then if you've been using this for a while, hey, why does this cost so much? I thought the whole point was that we're supposed to scale and be perfectly scaled. And why is it now costing way more than we predicted?
Yeah,
So what
it's
are some
cloud. We were not supposed to pay for anything we're not using, right?
exactly, that's the whole point of pay as you go. So then what are some of the things that go into cost here? And before we jump into that, actually, we might want to do a poll. Let's get our first poll. And when that pops up here.
Yeah, there should be a poll popping up right now. If you're on LinkedIn, I think the LinkedIn Live is working after all, then you probably won't have access to polls, or maybe somebody will post the questions there. But anyway, this is also a place to say that you can ask questions too. There's Q&A in the Zoom webinar, and you can of course post your questions on the LinkedIn live stream. And yeah, here's the poll. It's up. Okay, and anything that you post there will be sent to us on Zoom. So yeah, we'll be
Yeah.
happy to take questions as we go.
Yeah. So how do you select the nodes for your clusters? Do you make an educated guess? Are you using something like the Learn K8's instance calculator, which we'll talk about in a minute? Do you use node auto provisioning, or is it really just trial and error?
Yeah, okay. So take your time answering the poll and continue listening to us, because we're diving into what comprises Kubernetes costs. Okay, so definitely when we spin up a cluster, if we're running on a cloud provider, and we're assuming most of us are running on clouds, even though there are on-prem clusters too. So first of all, there's the control plane, and we're consuming this being, a fixed cost, especially on the cloud. This is something that's hidden from us. We're just getting access to the API server. We're not really controlling it. We can control a few things like turning on the control plane logging or not, but beside that, it's a fixed cost, and it's actually just a fraction of the whole cluster cost, right? And then we have the network. Networking is important to consider, because if you're running a cluster in one AZ, for example, on AWS, then you're not paying for network traffic between your pods. But if you spread your nodes into different AZs, then you're definitely paying for cross-AZ networking. So this is something to consider. And then there's, of course, the cost of storage, what kind of storage you're using. That also impacts the cost of the cluster. And of course, you want to be able to observe whatever is happening in the cluster. So it's another cost. Kubernetes, a lot of things could be going on, and we need to have observability. And I think, Matthew, you have a story
Yeah,
about that.
on the observability piece, I've had a lot of platform engineers tell me they choose their node sizes based on their observability platform charging them for more nodes. So, for example, I talked to a lot of people at Datadog DashCon in New York last month, and they said rather than using a lot of small nodes, they'll choose to just have a few massive nodes to run all of their pods on, because Datadog charges per node rather than, per usage of the amount of pods on that node. So that is another thing that goes into play when you're making these decisions.
Okay. So yeah, and another point to what we're talking about, right? Node selection is not a walk in the park. There are many considerations to take into account.
Oh yeah.
And of course, the nodes, they're the most important part of our Kubernetes cluster cost, right? And that's why selecting the right nodes is so important, because by the end of the day, everything else we have some control over. We can decide if we're running cross AZ or in just one AZ, and there are also business requirements that control that. But nodes, they're mostly impacted by what we're going to run. And
Yeah.
the question comes up, how many nodes do I need? How large do they need to be?
Right. Yeah. So then
How do
how do we solve that? Obviously, there's the guesstimating, and I don't know the results of the poll yet, but I'm assuming some people put that as their answer. How do we get away from guesstimation?
Now, the thing to understand is, first of all, of course, in order to decide the size and the type of the nodes, we need to understand the characteristics of our workloads.
Mm,
If our workloads are more compute heavy or memory heavy, and by the end of the day, how much resources does my container require for the load that I expected to carry, right?
right.
And you can't really define that without properly benchmarking your workloads. And of course, this is the first practice that we recommend. And there is a talk that we had in Prague at the Kubernetes Community Days with Ivan, the SRE engineer here at Perfect Scale, about how we use K6 in-house to load test what we do, because everything we run is in Kubernetes. So we're using K6 with K6 operator to load test our workloads natively in Kubernetes.
Hmm.
And the link is on the slide. Now, once we've benchmarked our workloads, or maybe we have some historical data. So, for example, if we're migrating from another system, we may have some data regarding how much resources our workloads need. Once we know what size we want our pods to have, at least once we estimate that, right, we can probably use the calculator, the instance calculator, like the one that was recently relaunched by LearnCates. And we actively help them with that because we think this is a great piece of software which helps us at the estimation phase, right?
Right.
Estimation phase only, but yeah, this can be valuable if we just want to, estimate what kinds of nodes we need, how many of those we're going to need, and by the end of the day, how much is it going to cost me?
Yeah, absolutely. And I like to think of this when I try to explain people requests and limits and like, help them understand that. I like to say it's like when you buy your laptop. I bought my laptop and it has 8 gigs of RAM and maybe 2 cores of CPU. But now when you're running an entire application, that's is going to need a lot more than that. But then how do you decide how much and then how many nodes? So this calculator lets you say your different pod sizes. So maybe you need 1.5 gigs of RAM and a half a core of CPU, and you can choose your cloud provider. So we'll just go AWS. We can look at the compute optimized or general purpose. I'll just, in this case, I'll say it's a general purpose machine. And then I can start to see the different recommended ones that will work as well as their size. And it gives me even more information on the right, and I can compare between different nodes. But Anton, tell me a little bit about these different options here and what when I change this, why are these changing?
So first of all, yeah, about the cloud providers, you don't have to choose, right? You can leave them all
Mm.
on, and then this even gives you an option to compare the offerings of different cloud providers. You could say, okay,
Yeah.
take the instances of the same size from each cloud provider, and then decide what costs me more and what gives me more capacity, et cetera, et cetera, et cetera. Then one more thing that we need to look at is on the left, it says daemon sets and agents, right?
Right.
Uh, no matter what size of the node we have, there is some capacity that we need to reserve for all kinds of system services that we want to run on the cluster. And these are like non-negotiable. And we also need to somehow probably benchmark those because where else do I get this information? And this is going to change over the lifetime of my system. So it's another complicated question to answer.
No, that's an
Uh,
interesting one because I was talking to a customer and we went through and we optimized all of his pods, but then there was the daemon sets that were left. And some of those in the kube system namespace we couldn't touch because Azure controlled them. So that's something that's really important to be aware of because that directly impacts the size of the node that you need.
exactly. And then, okay, once we've defined the size of the pod, yeah, we can click on different instances, and then each instance will show us the maximum amount of pods that it can have, right? And for each pod, we can see the cost per pod. And if we're like looking to be cost optimized, then we'll probably choose the instances that have the lowest cost per pod.
Right.
But then, sometimes the lowest cost per pod would mean we need to put something like 70 pods on that instance. Do we even have that many, right? How do I know how many pods I'm going to be able to run? So
Hmm.
this is a great tool that allows us to visualize this thing, and I think this is one of its strong points because otherwise, it's all very ephemeral and balancing all that data in your head is very hard, and it's hard to come up with any sensible estimations. The tool, the calculator, definitely makes it easier. but it has all of its limitations. And let's talk through this.
Right. Yeah, like you can only do one pod here, I guess, versus being able to know each of the different pod sizes.
Exactly. So, first of all, if we just wanted to run one type of pod with one type of size, then we would probably wouldn't need Kubernetes at all, right? Everything is predictable, so we just, spin up a few VMs, put our containers on them, and no Kubernetes smarts are needed.
Right.
Kubernetes, the magic of Kubernetes is being able to automatically spread the containers on all kinds of nodes, and the containers can be of different sizes with different requirements. The limitation of the calculator is it only gives us an ability to calculate for one type of pod, and then for each new workload, we are gonna need to calculate this differently. Now, what do we do now? Do we define a different node group for each workload? That would be like too much of complexity.
Hmm.
And then, of course, the sizes of the pods. Like, let's say we benchmark our workloads. Of course, the benchmarking preliminary benchmarking, it's great. We definitely recommend to do it, but it's limited in its ability to predict what's going to happen in runtime, right? Because we usually benchmark isolation. Our pods are not impacted by other containers that probably want to use the resources and they're sitting on the same node. So we don't really know how much resources they're going to need. And of course, the calculator doesn't take into account all other kinds of constraints, the observability cost that you already mentioned. And of course, there are some affinity and anti-affinity constraints which don't allow certain kinds of pods to sit together on the same node. And then even though we bin packed them in the calculator saying, okay, we're putting 15 pods on this node, but then they just can't reside on the same node and we need to spin up more nodes. And of course, even before we start thinking about the node sizes, we define if we want to auto scale our workloads, because that's one of the capabilities that Kubernetes and cloud in general gives us to be able to only run what we need and to run more capacity, run more instances of the same workload when there's more demand. So we probably want to define something like a horizontal pod autoscaler or KIDA. And then again, how do we account for that? How does that impact our resources? How do we put this data into the instance calculator? Do we put the maximum amount of instances? But then we're pretty sure to stay over provisioned most of the time, right?
Right. And I'd love
And
to see the answers to this poll here about the different ways people are using autoscaling. I know when I talk to people, there's usually three types. There's people who are not using any sort of autoscaling at all, and then they're not getting a lot of the benefits of Kubernetes. And then there's the people who are using it and it's working really well, and they're actually very well tuned. Maybe they're using Kata to look at the queues of the requests into their service, and then they're scaling out and adding additional pods as needed, rather than using CPU request or memory request as a threshold. And then there's people who are using it, but they set it a couple years ago and they haven't looked at it, and it's actually just making things worse. And then it's just creating more and more pods, which are then replicated by the cluster autoscaler and creating more and more waste. And that is something that's really hard to identify with just the native tooling.
yep, definitely. And that directly relates to the last point that I wanted to cover. Like you can just set up things once and forget about it most of the time, right? Because our systems are in constant flux. We're doing continuous delivery. We're constantly updating, improving, adding new features. The code changes, the load changes. Hopefully, our product is successful and we have more and more users. And then there's the seasonality. So things are in flux, and well, the calculator is assuming some static situation, and of course it's never like that.
Right. And that makes me think about not just the horizontal and vertical autoscaling, but Carpenter. And that was one of the things I wanted to discuss. If you're using Carpenter and Node auto provisioning, we're expecting that this is going to handle that for us, right? It should be doing the proper scaling. So does that not solve the problem?
Yeah, definitely. That's a question we often get. Like, okay, why even think about the sizes of the nodes? There is Carpenter. It's smart. It can optimize for cost, and it will choose the nodes for me. I just need to configure it, and I can go drink beer, right?
Yep, right.
So uh, it does bring good news. We definitely don't need to select nodes manually for each new pod that's scheduled and pending, waiting for resources. And Carpenter will try to optimize and bring the nodes that are the cheapest and that give us the best utilization. But first of all, if we want to leverage, cloud discounts, things like spots, preemptible VMs, or reserved instances, we still have to configure, right? Need to configure the ratios, and this is something we need to configure. We're not guaranteed we'll configure it correctly right away, so we need to be able to monitor that and optimize it as we go. Also, things again like affinity, attached storage, all kinds of constraints. They can impact what Carpenter can do. They can limit Carpenter's ability to bring up nodes efficiently. So we still need to monitor. If it's happening, then we need to optimize these things. And finally, Carpenter has no idea how much our pods really need, how
Right.
much resources they really utilize, because the only thing it looks at is the request that we've set for our pods. Now, as we already said, we usually set the requests or by guesstimating, saying, okay, this is probably a Java application, so I'm supposing it will need something like 2 gigas of memory, right? And that's not necessarily true.
Yeah.
And even benchmarking doesn't provide us with the correct data, so we need a way to continuously evaluate the actual utilization. And only when we have the actual utilization, we can set the request correctly, and only then Carpenter can actually bring us the nodes we need. Otherwise, it's optimizing for the guesses that we made beforehand.
Yeah, exactly. And I know you posted a blog about that actually, how working with Carpenter and Perfect Scale, we are able to save even up to 80% more. Because when you have the inefficient pod sizes, so we call that waste, right? The difference between what you've requested and what you're actually using. If you just take that and replicate that to more and more nodes, which is what Carpenter is doing, it's taking that waste and just multiplying it. So let's say that waste cost you $100 a month for one node, and then you scale up to 10 nodes. Well, now that's $1,000 a month. And that's something that having a tool like Perfect Scale will help you solve. So tell me a little bit about what you've seen Perfect Scale do for some of our customers and how it can actually, once we're done right sizing at the beginning, continually right size and give you runtime insights.
Yeah, so Perfect Scale definitely improves. First of all, it allows you to actually select the nodes you need. And it starts again with runtime insights. So we continuously, Perfect Scale continuously monitors all of the containers in the cluster. And that includes also ephemeral stuff like jobs that may have been running yesterday and not running today anymore. You still have the insights for those. And it shows what was the actual utilization for these containers, and it also gives you smart machine learning driven recommendations for how to set these requests responsibly, right? The way we like to frame this, we're doing responsible cost optimization. We realize that people don't want to get under provisioned because nobody wants their workloads to fail or get throttled.
Yeah.
So yes, we're leaving some overhead in order for your workload to continue running reliably, So we give it these recommendations, and you can set the recommendations. And now with the new infrafit feature, you can also see how these optimizations to pod right sizing, how they are impacting the utilization of your nodes. So we have like, I think the visibility we provide into node efficiency is really like nobody else in the industry. Uh, you can look at your nodes, and in a minute he'll show us in the demo, and
Right.
easily identify which nodes, which node pools are not utilized in an optimal way, and then take steps. And of course, we also do alerting if we encounter issues with, over provision, under provisioned requests and limits, or things failing. And in the end, when you're happy with the recommendations that you're getting from the system, you can set it on automate, and it will continuously optimize all of your workloads autonomously, and your clusters will continue working like a well-oiled machine, lean
Yep.
clusters that let you sleep at night quietly.
Absolutely. And I'm going to give a brief demo here of Perfect Scale. If you would like to see this live with me, feel free to go to our website and book a demo. It's just perfectscale.io. You also can start with the community edition. So it's free to use up to a certain amount of nodes, 200,000 vCPU hours per month. So if you want to go ahead and kick that off, you could even add your cluster. It's one click. You click add cluster, then copy the Helm repo, and then you'll give your cluster a name. So I'll just call this test, give it a policy. This is saying how you would like it to be optimized, how much headroom you want to have, and then you generate this secret. Run this command, and we will start collecting data. So once we collect that data, we bring it into our SaaS solution. And I can see here in my test environment, we've got 5 different clusters. Across the top, I could see what are my resiliency risks, what's my cost per month, my waste per month, and idle. So waste and idle, again, I said earlier, waste is the difference between how much you've requested and how much you're actually using. And then idle is that extra headroom. If you have wasted space because you weren't able to fit extra pods into your environment or into your nodes, or if you have cluster autoscaler or something like that that's reserving some extra headroom. If I want to then dig in and see each individual cluster and what node pools and types are running on that, I could go into our infrafit feature. So here I could see with this particular cluster, our node cost has been increasing. So this is cost for every couple hours, and it's been increasing lately. And I could see my top node pools. But if we wanted to dig into specifically why, I could go look at my CPU and my memory. And this being so dynamic immediately tells me, okay, we're using cluster autoscaler or Carpenter. In this case, we're using Carpenter and it's scaling up. We're also using spot nodes to get even more savings. And here I can see in the past, I was requesting maybe 50% or 100% more than what I was using. But now lately, I've been requesting almost 3 times as much. So that's what we call waste. And Perfect Scale helps you close that gap. It's the same thing on the memory here. We were pretty tight, but then we started to see this big gap. So some new workloads were introduced or something was created, and we're going to now figure out how to find that thing. So what I can do is see my different node groups and very quickly see, this is my largest one. It's costing me 1,800 a month, and it's got the most idle cost as well. I've requested 95% of my different node types, but then I'm only using 60%. Same thing with memory, requesting 86, but I've got 14% idle. I can click into this group and now see all the different node types. So there's a lot of different ones. Sometimes they spin up, sometimes they spin down. And in our case, we're using all spot instances because of our dynamic nature. And around July 16th, we definitely started seeing a lot more waste. And if I wanted to go see where some of that waste is, I want to look here for differences. So like this, for example, there's a big gap between what's requested and used on this M6A 2 extra large. I can filter on that specifically. See here, yep, that's when that big spike happened. And I can click into this. I see all the information about it. But if I want to see specifically what workloads are running on that machine, then I could start to do the optimization that Anton was talking about. So here I could very easily see all of my workloads and I could sort by waste and see which are wasting the most. I could also click in and I could come see where we have risks. So first thing I want to see is where do I have over provisioned CPU requests, because that seems to be the problem. And I've got a handful of different things here. So with one click, I'm now seeing um, these um, these workloads, and then I can click in and see more details about it. In this case, this is one that has automation turned on. But if I wanted to go see deeper and find some maybe that don't have automation turned on, I can go to the pod fit view. So this gives you really deep insights into what is running on your cluster. And I can then see the waste very quickly with one click, see what's the top waste. And in this case, I've got this daemon set running here. It's Loki HA Promtail. And there's a chance here that I could save about $40 a month if I were to just reduce this request from 167 to 136. Same thing, I could reduce the CPU from 249 to 81. To do that, all I could do is I could just copy this code and apply it to the configuration file. And that's really how helpful this is. With just a couple clicks, rather than manually looking at some trends in Grafana to identify what's our usage, Perfect Scale does all that for me. And it tells me exactly what I need to set my requests and limits to.
Oh, what's that delete tasks down there? There's a button there.
Yeah, so let's say you're not the person who's responsible for this. You can create a task and it would be routed to the proper team. So in this case, it's Anji, and he would be assigned to make this change. And then he can click, immediately take you back to perfect scale and see what is the recommended change.
Yeah, and that takes us back, to the beginning of the webinar where we said you need to know how much resources your workloads require. And for that, you definitely usually need a collaboration between the developers and the operators. The operators don't define this, they don't write the code, and they shouldn't even be responsible for testing the workloads before
Yeah.
they're getting deployed, right? So yeah, definitely perfect scale makes this much easier.
Yeah, that's a good point. Now, I see a couple different things. I see a lot of people using Perfect Scale are platform engineers who aren't necessarily developers, or they're the DevOps team who is maybe building automation and building continuous integration, continuous deployment, and they're not the ones making these changes. And also, we want to get buy-in from the developers to trust, hey, you actually do have the chance here to reduce from 5 GB of memory to 3.6 based on your usage that you've never gone over 3.8. There's not a lot of trust there. Someone might say, hey, why is it costing so much? But they can't necessarily justify it. And that's something that we're able to give justification to those development teams.
Okay.
So another
And
thing Perfect Scale helps with is identifying the risks. So it's not just about cost reduction. You mentioned earlier we want to make sure we have enough resources, right? So if you come into alerts, rather than looking just at one cluster, we'll aggregate all of your performance issues into one view. So I can see here I have all of my clusters, and I can see I've got a couple different things like out of memory, under provisioned memory limit. And so I've got this out of memory here. I can click on it. Clearly, I've seen that this was sent via Slack to our Perfect Scale support team. Hopefully, they're investigating it. But if I wanted to see more details, I can see here there's been 50 out of memories that have occurred. In this case, the limit is set to 2 gigs, but we're continuously hitting 1900 megabytes. So we're getting really close to that. So we need to up the limit a little bit. In this case, there's 3 replicas. So if one goes down, it might be okay. But if they all go down and it starts to cause this waterfall effect, then the whole application could go down. So that's the other side of this. Then over time, if you want to get views into how your nodes look, we can come in here and we can see up to 13 months of data, your node reservation. So for example, when we first started out a year ago, we were just using on-demand instances. And then we started using Spot. We started adding more and more. Now you can see we're almost a third to almost half of our nodes are spot instances. And that's going to be one of the biggest ways to save money. And when you're using Carpenter, it knows about these pricing, and it can recommend where you should use spot instead of on demand. You can also look at your node types, and I could see all of my different node types. And if I wanted to select a specific cluster, see what node types have been used. So for example, I'm starting to see this huge spike in the M5A 2 extra large. I could go back to Infrafit and see, okay, what's causing that? And I could see specifically which workloads. So I'll go back there. We'll go to this node types. M5A 2 extra large. Let's go to the workloads chart. So, yep, same thing we saw there. This one workload has what's been the biggest cause of that increase, as well as we're starting to use a lot of others. I can see this spike here. This pricing tool is starting to use more, but I quickly can identify what workloads are actually causing my cost. And when you're having to report your costs, normally Amazon or a provider doesn't give you workload level details. They're giving you, you're paying for nodes, right? You don't pay for workloads. And then with perfect scale, you can see what workloads are running on those nodes that you're using for Kubernetes, and then actually do chargeback or showback or whatever you want to with that data.
Or you can even charge the developer.
I don't know that that's a good idea, but definitely the teams. Um, Unfortunately, that's not my not my responsibility. So again, this is something, if you wanted to try this out, just go to perfectscale.io, click the getting started button in the top right. We also have a lot of really helpful resources and blogs that might help you if you're just wanting to get started in this Kubernetes space. And now I just want to transition to a time for questions. We've got a handful, I see, in the Q&A. So let's start with the first one here. Doesn't VPA Carpenter solve the problem?
Okay,
Anton, I
but
know we talked about that a little bit. Obviously, so Perfect Scale kind of is a replacement for VPA. It's an intelligent VPA. And then Carpenter, without Perfect Scale, solves part of the problem. Um, but if you want to highlight again what you said earlier,
yeah,
Anton.
well, we already talked about Carpenter. So Carpenter doesn't know how much resources our containers actually need and utilize. So that's where Perfect Scale helps you. But somebody would say, yeah, VPA does that for me, right? And I also see somebody else mentioning KRR there, which is also a great open source tool. But they all do a little bit of what Perfect Scale can do. Definitely, yes, they do provide recommendations. Now, VPA specifically is known for its inability to work together with HPA, right? And also, VPA doesn't know anything about your nodes. And Perfect Scale, as you already seen, does know what nodes you have in cluster and what node pools you have in the cluster. So when we provide recommendations, we take that into account. While VPA can give you recommendations that none of your nodes are going to accommodate for.
That's a good
And
point. We're looking at where you're using HPA, and we're aware of that. So we're not going, let's say you have HPA set to an 80% CPU request. So once your pod gets to 80% of the request, then it's creating another pod. We're aware of that, and we're not going to reduce the pod size less than that. VPA it won't work at all with CPU requests. You have to use some other triggers. Otherwise it might break it.
yeah, exactly. So basically, the recommendation is not to use the VPA and the HPA on the same metric.
Yeah.
And of course, the history, like what you showed about the trends, being able to see the trends like a year back and to analyze, like both VPA and KRR and Carpenter, they will recommend you stuff, they will bring up the nodes for you, but in order to actually analyze their efficiency and effectiveness, you need to set up your own monitoring all around that and to see how these recommendations are impacting your overall cost and performance, while Perfect Scale gives you that out of the box.
So, how frequent does Perfect Scale pull and give us recommendations? We're pulling kube state metrics and cAdvisor every 30 seconds. We send that data out every 10 minutes to our SaaS solution, and then it's giving recommendations as it sees fit. One of the cool things that's not exactly what you asked, but another follow-up question that you might be wondering is how does Perfect Scale implement its automation? Meaning, if it sees the opportunity to reduce waste, how does it do that? Or if it sees the opportunity that there's a lot of out of memory, we need more resources, how does it do that? So when we see resiliency issues, we immediately add resources so that we can remove those issues. When we see opportunity to reduce cost, some tools out there will just slash it down. So let's say you have a chance to save 80% of your cost, it just cuts it down. We take more of an iterative approach. So we'll cut it a little bit, wait a few days, drop it a little bit more, wait a few days. Because at the end of the day, the goal of running an application on Kubernetes is to make sure your application has the most uptime and that you can run it with the least amount of resources. And if you just go and slash all of your prices, you're going to introduce some resiliency issues. So Perfect Scale is always prioritizing making sure that you have enough resources at the lowest possible cost.
Yeah. By the way, another thing that we haven't mentioned, Perfect Tail is also revision aware. So, for example, if you take VPA or KRR, again, they're great tools. They can provide you recommendations. They measure the actual utilization, but they treat every workload like it's always been the same and it's always going to be the same. What we realize is that fact that I already mentioned before, our systems are in constant flux. We're doing continuous delivery. So each new revision can bring a change into how our application is using its resources. And we do realize that when we start measuring in U for each new revision. And you can see that in history, there is a great visualization for that in the interface. So
Hmm.
definitely, that's
Yeah.
another point we have for perfect scale.
Yeah. So another hotly debated question. There's a recommendation, never set CPU limits. Anton, I'll let you go first. What do you think about that?
Okay. So in general, we agree, but okay, there are could be certain situations where you do want to set CPU limits. Uh, One such situation is when you're benchmarking your workloads again. Okay, so because if you're benchmarking without CPU limits, then your pods or your cluster is assuming there are actually no limitations, and the pods can always use the whole of the node where they reside on, right? But in real life, my pod is not alone on the node. There are other pods, other workloads. They also want their share of CPU. So my pod is going to be throttled. My pod is going to be limited. So I need to account for that. I need to understand how is it going to behave if it's not getting enough CPU for what it's trying to do, right? So that could be one reason to use CPU limits. Now, once you've set CPU limits in staging or in testing, the question becomes why not just set the same CPU limits? If I've already tested it with the limits, why not set the same CPU limits in production? And again, once you've pinpointed your exact node utilization, once you've found out all of your noisy neighbors and you've placed them, maybe decided to place them on the nodes where not that noisy for other neighbors anymore, then you may want to set the CPU limits back. Again, these are all corner cases. In most cases, if you want to get most productivity and most performance, then definitely don't set CPU limits. By the way, there is also this known fact that Google always sets CPU limits for their production workloads, and that's because they prioritize consistency over performance. They're saying we want our workloads to behave in a consistent way, right? So again, if you prioritize consistency, and it is important in the business context, over performance, and don't want just to squeeze out every ounce of performance out of your workloads, then definitely you can set those CPU limits back.
Right. And definitely set memory limits because memory is not a compressible resource. Remember, CPU is actually just time. It's how much processing time, and it's hard to know how long it's going to take something to run, especially when you are setting it to fractions. And so there's a lot of great blogs on this. We could talk about it all day. But I can say one of our customers, after many conversations with our CTO, Ellie, they now do not set CPU limits. And they tell me every single monthly customer success meeting, you've saved us so much downtime ever since we stopped setting CPU limits. And I try to convince others, but there's definitely edge cases where you might want to set them, especially if you're having certain types of Java applications or different things. So do your research, but we recommend always make sure you properly set your requests because if you're not properly setting your requests, then machines or pods might not be asking for as much as they truly need. And if everyone asks for how much they actually need, then it should work properly. Then, as things change over time and the needs change, that's where you need a tool like Perfect Scale to tell you and automatically change those requests so that everyone's always asking accurately for what they need. When I say everyone, I don't mean people, I mean the pods, but that is all set manually by people unless you're using something like Perfect Scale to automatically set those requests.
Yeah, yeah. So again,
One last question I had from somebody, Anton, I wanted to get your opinion. So, in your experience, is it better to run smaller nodes or fewer bigger nodes?
uh, okay, in general, smaller nodes is always better because it allows you for more control over your scaling. So when you need to, reduce capacity because it's not getting used, that means you can scale down faster. Because if you're using a large node until it's empty, you cannot really deprovision it. Okay, and again, when you're scaling up, you're not over provisioned until the node fills up. But on the other hand, there are other constraints there, like the one you mentioned with observability. A lot
Yeah,
of nodes means a lot of monitoring, a lot of observability, a lot of noise, and that could cost you, and that can make your environment more complex. So yeah, there are operational concerns that you need to take into account.
absolutely. Well, Anton, I think this has been great. Thank you so much. How can people get connected with you if they want to hear more?
Yeah, so you can definitely find me and Matthew on LinkedIn. If you're watching this on LinkedIn, you already see our contacts. And oh, we have another question. When it comes to autoscaling, what metrics does perfect scale consider?
I'd love to hear clarity on what they mean by that. But in general, we are scaling vertically your CPU and memory requests, and then we're also changing limits. One of the ways that some other things we consider if you have an init, so if at the start of an application it's using a lot more resources, we'll consider that. We'll consider if you're using
Which
HPA
can
or
be a case,
CADA.
which can be a case for JVM applications, for example.
Right, right. We'll consider um, any sort of seasonality. So if you have times where there's a lot of downtime versus times where it's very heavy, we'll consider that. And then again, yeah, it's CPU and memory. We're not currently looking at storage or GPUs or anything like that yet.
Yeah, and we also allow you to define a reliability profile for each desired reliability profile for each workload. So you can define if you want to have it more headroom or less headroom, and
Yeah.
then we'll
And
allow for that.
they said if they might have a scheduled process that runs for a few minutes, right? So I guess I would almost consider that a job, but it might not be a Kubernetes job. It might just be running on a Kubernetes deployment that has jobs run on that machine. But in that case, we'll capture that. When it comes to jobs, we aren't currently automating those, but if it is a deployment, we would see those spikes in usage, and we would capture that into the request recommendation if it's something regularly scheduled. For example, every day at midnight doing a backup, that type of thing.
Yeah. So yeah, coming back to where people can find me,
Ah,
I'm
yes.
also on Twitter as Antwiss. It's Antwiss,
Awesome.
and I'll also be speaking at Sivo Navigate in September, September the
True.
10th.
Yeah. And I'll be at KubeCon in Salt Lake in November. That's actually on my birthday weekend. So very excited for that.
Birthday.
Yes.
Oh,
Awesome.
so
Well, Anton, again, thank you. And everyone who attended, thank you guys so much. Check out our website, perfectscale.io. Get started with your 30-day trial and start optimizing your nodes today.
yep, definitely keep them lean.